Hello, my name is Taylor Ball, and today we are going to be talking about feedback loops in the non-gravid female reproductive system. Let's get started. I want to first start by talking about the anatomy of the female reproductive system. The anatomy includes ovaries, fallopian tubes, uterus, cervix, and vagina. The ovaries are the female gonads, and their function is to shelter and protect the eggs until ready for use, produce female reproductive hormones, which include estrogen, which give the females their characteristics, which would be breasts or wider hips than males. And it's also used in the reproduction cycle, which we'll talk about. Progesterone is the reproductive cycle as well. We'll talk about that a little bit later. Inhibin prevents pituitary gland from producing hormones. And then relaxin is used to loosen pelvic ligaments during labor. The last function of the ovaries is to release the egg once a month. Once this egg is released, you can see here it's released out the ovary, and then you see these finger-like protrusions. These finger-like protrusions are on the fallopian tube, and they are called fimbriae. They are also lined with cilia, which help the egg to move down the tube into the uterus. The uterus is a hollow muscular organ, and once an egg is fertilized, it can implant in the lining of the uterus. The uterus also has 3 layers, which include the endometrium, myometrium, and parametrium. From the uterus, there is at the bottom here, it goes into the cervix, and then from the cervix, it goes into the vagina. So what is a feedback loop? A feedback loop is a biological mechanism whereby homeostasis is maintained. The output of a system amplifies the system, which would be a positive loop, or inhibits the system, which would be a negative loop. An example of a positive loop would be childbirth, blood clotting, and milk secretion. And then an example of negative would be the menstrual cycle. So I know I said before that we were going to be talking about the non-gravid female reproductive system, which just basically means the female is not pregnant. However, a great example of a positive feedback loop is when the mother is about to give birth to a child. So I wanted to include this here in my lecture. So I'm going to start here. During childbirth, the head of the baby pushes against the cervix. Nerve impulses from the cervix is transmitted to the brain. The brain stimulates the pituitary gland to secrete oxytocin. The oxytocin is carried into the bloodstream to the uterus. And then the oxytocin stimulates urine contraction and pushes baby's head towards the cervix. This then starts the cycle over again. The head of the baby pushes against the cervix. The signals are transmitted. Then it goes on and on until the baby is born, and then that's when the loop stops. So an example of negative feedback loop, which as I said before, was the menstrual cycle, and just a little bit of background information on that. The menstrual cycle happens about every 28 days, and it consists of the ovarian cycle and the uterine cycle. The ovarian cycle is divided into 3 phases, which include the follicular phase, ovulation, and the luteal phase. The follicular phase is a period of follicle growth in the ovary and can last anywhere between 10 to 21 days. The ovulation is when one or more of the follicles have ripened and the ovaries release the oocyte during ovulation. And then lastly, the luteal phase is the transformation of the follicle into the corpus luteum, and the corpus luteum secretes hormones that continue the preparation for pregnancy. However, if pregnancy does not occur, the corpus luteum ceases to function after roughly 2 weeks, and the ovarian cycle begins all over again. So the ovarian and the uterine cycle are under primary control of various hormones. These hormones include GnRH from the hypothalamus, FSH and LH from the anterior pituitary, and then lastly, estrogen, progesterone, inhibin, and AMH from the ovaries. So right hand corner here I have this diagram which kind of follow along as I explain the different feedback loops in the menstrual cycle. Starting with the blue loop, we're going here. FSH and LH are secreted to start the development of the follicle. These two work together to start estrogen secretion. Estrogen has a negative feedback loop on FSH, which causes it to stop being excreted. So as you can see here from the anterior pituitary, FSH, LH goes down to the growing follicle, to estrogen, and then back up for the negative feedback loop. Next, we'll talk about the red loop. The red loop increases the amount of estrogen that is experienced at the midpoint of the cycle. The increased estrogen causes a positive feedback loop to occur on the LH cells in the pituitary. The LH secretion rises and ovulation occurs. That's this loop here. And then lastly, we're going to talk about the purple loop on this side. So the purple loop, after ovulation, the follicle cells are transferred into the corpus luteum. The corpus luteum secretes estrogen and progesterone. The buildup of these two increases the formation of the endometrial lining. They work together to send a second feedback loop that inhibits the release of FSH and LH. This causes the corpus luteum to deteriorate, slowing down the production of estrogen and progesterone. The decrease in hormones starts the cycle of menstruation. So lastly, I have a slide that shows basically a little bit of everything in one picture. So I thought this was kind of a nice overview of everything that we've talked about so far. So starting at the top, in the ovarian cycle, you can see the egg growing, the follicle growing, and then ovulation where the egg is released, going into the corpus luteum where it's starting to dry up and fall, and then going back over into the cycle again here. So the body temperature as we go through this kind of spikes when you're in the luteal phase, which would be this section here, and stays steady until about day 28 where the cycle starts all over again. This is also a nice section here of the anterior pituitary hormones, which are the LH and the FSH. And starting at roughly day 14, which is the luteal phase, you can see a spike in the LH as well as the FSH. The next portion is the ovarian hormones, which here you can see how they rise and fall. The progesterone kind of stays a little bit heavier during the luteal phase as well. And then the reason why I really like this picture is of the uterine cycle, which we didn't really talk much about, but I think this slide here gives a good representation of it. So this would be the end of a period here. And then this would be the start of the new cycle. You can see how they kind of flow into the one into the next. And this is the uterus as the lining of it grows during the cycle. So as you can see here, it grows and grows and grows, and then it kind of sloughs off and you have your period. So this is just kind of a good recap of everything. I hope you enjoyed my lecture and have a good day. Thanks.